Good morning. Let me turn off my autofocus here. We're going to look at a function application with a graph, and you can see I've got some graph paper set up here, so if you're taking notes, you may want to use some as well. So let's look at a function application with a graph. And so we're going to answer some questions based on the graph of a function along with the function's equation. So answer the questions based on the graph and its equation. Answer the questions based on the graph and its equation. So this graph is going to represent cab fare. Okay, so that'll be the title of this graph. And so our x-axis will be miles traveled. And our y-axis will be the cost of the ride, and we'll say that that's in dollars, okay? So miles traveled versus cost of the ride. And so what we need to do is set up our axes. So I'll do that right here. This will be my x-axis, and then this will be my y-axis, or my c of x axis. We're going to use the function c of x for this example, c representing cost. And so actually on the cost axis, we're going to skip some values here. So a common way to indicate that on a graph is, right, we're going to start at 0 for both the x and the y-axis. But on the y-axis or the c of x axis, we're going to skip some values that we're not going to use. So we sort of indicate that with this break in the y-axis, okay? And so once we've done that, we will set up our y-axis. We'll make the first y value we look at, we'll make it 5. So let me move over here. It's easier for me to write. So we'll say this is 5. And then we'll go up by ones. So 6, 7, 8, 9. And then I'll label this one as 10. And the labels help me understand the scale. So that's kind of important. And then 11, 12, 13, 14, 15. So I'll label every fifth on the y-axis. Then I'll label my x-axis values as well. So we'll go by ones on the x-axis. I won't label the first one as 1. Maybe I'll label every fifth one on this axis too. So there's 2, 3, 4, 5, 6, 7, 8, 9, 10. 11, 12, 13, 14, 15, and so on, okay? All right, so we've got our axes set up, we've got our labels done, we understand what the graph is going to represent. Now let's actually graph the function, which in this case is going to be a straight line. So over here on the y-axis, it's going to start at 6. And then let's say at 10, the y value will also be 10. And then we'll just connect those points with a straight line. If you're on paper, it'll be easy to use a straight edge. I'm looking around my garage here to see if I've got something laying around. I think I do. Okay, so if I were to draw this with a straight edge, then it might look something like this. Okay, so our graph looks something like that and keeps going, right? The more miles you travel, the more your cost goes up. And so now we're going to answer some questions about this function. We need the equation of the function first, so let me give you that. So let's say that in this equation, c of x equals 0.4x plus 6, okay? C of x equals 0.4x plus 6. So let's answer some questions now. So let's do this. Let's, from the graph, determine C of 0. From the graph, determine C of 0. So what this means is we go to our graph. The value in the parentheses is our x value. So we locate that x value, which is right here at 0. And C of 0 means find the output of the cost function, the C function, when x is 0. So you can see here, when x is 0, this graph outputs 6. So C of 0 equals 6. Okay? Just finding the output of the function when the input is 0. Part B. For part B, let's use the equation to determine C of 0. Use the equation to determine C of 0. So in this problem, the equation is C of x equals 0.4x plus 6. So if we use that equation, we see that C of 0 equals, and all that means is plug 0 in for x in the equation now. So that I'm going to have 0.4 times 0 plus 6. And if I evaluate that, 0.4 times 0 is 0 plus 6 is 6. Okay? So luckily, whether we use the graph or the equation, we get the same answer. Okay? So that's one thing I want to illustrate in this video. Part C. Explain the meaning of the value for C of 0. Explain the meaning of the value for C of 0. So what is that saying? Well, so C of 0, we know from parts A and B, C of 0 equals 6 for sure. And the graph gives us context here. It's saying that when x is 0, C of x is 6. When the miles traveled, because that's x, when the miles traveled is 0, the cost is $6. Okay? So when we travel 0 miles, the cost is $6. So in other words, before traveling any miles, the cost is $6. Sometimes this is called the fixed cost, meaning before anything is done, this is just the cost to get into the cab, just to get started, right? This is your initial cost or your fixed cost. You can see that after that moment, after you travel past 0 miles, the cost starts going up. All right, so here's a good introduction to the function and its graph. Let's ask some more questions. Let's ask one more question. How about that? We don't need to overdo it here. I think we'll get the point across. Part D says determine, how about C of 12 and its meaning. So this is a two-part question. Determine C of 12 and its meaning. You may want to try this on your own. So C of 12, if I look at my graph, C of 12, you can see here I don't land on a lattice point. I don't land where two nice grid marks intersect. So I can't look at the graph and get the exact value of C of 12. So instead I'm going to use the equation. The equation is nice for that reason. I can plug any number in that I want. So C of 12 will be 0.4 times, well, just replace x with 12 plus 6. Well, 0.4 times 12 is 4.8, and 4.8 plus 6 is 10.8, okay? So that's the first part of the question. C of 12 equals 10.8. what is the meaning? So let's describe the meaning. Well, if we use the graph for context again, it's telling us that, well, x is miles traveled, and here x is 12. So if we travel 12 miles, the cost is going to be $10.8. So if we travel 12 miles, the cost will be $10.8, and that seems to look about right on our graph. Okay, the y value here is between 10 and 11 and closer to 11. So the meaning then is it cost, we don't say $10.8, we say $10.80. It costs $10.80 to travel 12 miles, okay? And so you might start seeing things that, well, all right, the initial cost is the 6 that we said, and then after that you're gonna add $0.4 for every mile that you travel. So if you see that also, that's fantastic. But basically, you should be able to look at a graph, an application graph of a function, and get outputs. You should be able to use an equation to get outputs, and you should be able to give the values of those outputs meaning based on the context of the particular graph.